and then I'm going to give you the problem, and we're going to use an example that goes something like this. 2 boats travel towards each other, or traveling towards each other. Crash in 20 seconds from when they started. So we'll just say in 20 seconds. If the boats were originally 1,000 meters apart, period. Okay, so they are traveling towards each other and they crash, but they originally started 1,000 meters apart. One boat was 4 kilometers, or sorry, let's go with meters because we're using meters. One boat was 4 meters per second faster than the other. And what I want to do is find the velocity of each of the boats, or the speeds of the boats. So this is where we're going to do one of those problems where you're looking at understanding the distance, speed, and time relationship. So you'll have to remember that speed is equal to distance times time. Or sorry, not distance times time. Distance over time. Or if you like, distance is equal to speed times time. Okay, and that's the relationship between distance, speed, and time, and often that relationship is important when solving problems in this world of math. So let's help ourselves out with a little bit of a diagram. So let's say let's define the variables first, and then we'll put the diagram. Let x be the speed of boat 1, and let y be the speed of boat 2. Okay, so we know that they were 1,000 meters apart. So here's the 2 boats and they crashed here somewhere in the middle. And that this was 1,000 meters. And we know that it took some time. Okay, and what was that time? 20 seconds. So each boat traveled 20 seconds. And we know that this boat here was going some speed, let's say x. And this boat here was going some speed y. So they eventually crashed. So looking at that information, we know that this distance plus this distance is going to be equal to 1,000. And we know that also it tells us that one of the speeds is 4 more than the other. So we can write out 2 equations. So let's write out 2 equations. So let's write out the easy equation first, that one speed is 4 more than the other. So x plus 4 is going to equal y. Okay, that's the relationship of the speeds. The other equation may be a little more difficult to come up with. We know that we're going to have to relate the two distances here together. So how do you get distance for this here boat? Well, it's just distance is equal to speed times time. So there's the time and there's the speed. So we could say that that distance, 20x, plus the distance over here, which would be the other side, plus 20y, is going to give us the total distance that they had, which is 1,000. And there's our relationship between the distances traveled by each. So now all we have to do is use the substitution method again. I'm just going to check, make sure my field of view here is going to be large enough for me, so I'm going to slide up a bit here. Just hold for a second here. I get a phone call here. Sorry about that. Okay, so we'll continue by using the substitution method to solve this problem here. So let's sub in y from equation A into equation B. So 20x plus 20 times y, which is x plus 4, is going to give us the 1,000. I had 100 there. 1,000. Because that's what the distance between the two are. So let's work this out. 20x plus 20x, and 20 times 4 is 80, plus 80 is equal to 1,000. So 40x plus 80 is equal to 1,000. So we subtract 80 from both sides. 40x is going to equal 920. Okay, so then we're going to divide by 40 on both sides for our problem here. Just get that out of the way. So 40 divide by 40, divide by 40. So x is going to equal, for this case here, let me get my calculator out here. Okay, we got 920 divided by 40, which in our case is 23. So that's the first speed for that one boat. So given that we know that that is 23 now, we can find out what y is, because y is equal to 23 plus 4, which is equal to 27. So we'll check it out now. 20 times 23 plus 20 times 27 should be 1,000. Okay, so we'll work those out. 20 times 23 is 460 plus 20 times 27 is 540. So that would give us a check. So now we can say the boats were traveling at 23 meters a second and 27 meters a second. Okay, the faster one going at 27. So that's that problem solved for us. Problem with the boat, a speed problem. I've got one more here that I'd like to do before I end the tutorial here. And this one deals with looking at particularly combining things together, maybe doing sometimes you see it as a money problem, sometimes you see it as a